We're going to talk about rationalizing the denominator, and you've done this with this first problem, but let me give you more of what it is. Remember, I have a second root here, and I have one of these. Well, to rationalize the denominator, I have to multiply something by the top and the bottom. Well, if I have one of these, and I have one more of them, I have a total of 2 of them. And I want there to be just as many as there are right here. So what I do to the bottom, I do to the top. If I multiply the top, I get 4 rad 3. Outsides times outsides, insides times insides. If I multiply the bottom, I get the second root of 1, 2 of 2 of them. So I can also write them like 3 times 3. So my final answer is, well, if this is 9, what's the square root of 9, which is 3 on the bottom and 4 rad 3 on the top. When we rationalize the denominator, our goal is to get rid of the radical on the bottom. All right, here's the tricky one. This is 4 to the first. So I have to multiply something by the bottom, and a lot of times I do it where I can say, oh, well, I need 4 to the third. So what am I missing to get 4 to the third power? If I have 1, I'm missing 4 squared. Because 4, 4, and 4 gives me 4 to the third power. So what I do to the bottom, I do to the top. When I multiply the top across, I get 2, the third root of 4 squared, which I'm going to call that 16. So my last step is to simplify the bottom. When these are the same, they cancel. So I'm left with 4 on the bottom and 2 third root of 16 on the top. Well, I can go one little step further here. 2 goes into 2 one time, 2 goes into 4 twice, so my final answer is the third root of 16 over 2. So let's dig a little deeper into this. All right, my goal here is to rationalize the denominator. So the first thing I'm going to do is multiply it by something, and again, I like to figure out what's my equal going to be. So if this is the fourth root, and I have x to the third, I need x to the fourth, because I need multiples of 4 because it's root 4. Y squared, the next to get to 4 would be y to the fourth. So I know if I was to simplify this, I can pull groups of 4 out. Well, what is it missing? If I have an x to the third, I am missing one more x to get to 4. And if I have y squared, I'm missing 2 more y's to get to 4. So I multiply the top and the bottom by the same piece. When I simplify the top, I get the fourth root of I have 1x and 1x for a total of 2. I have 1y and 2y's for a total of 3. Now my goal is to simplify. Well, the 4's cancel and I have xy on the bottom, and on the top I have the fourth root of x squared y to the third. Let's try one more because this is a little bit different. So I have the third root, or 3 over the third root of a squared b to the fifth. So my goal again is I'm going to multiply it by something to give me multiples of the denominator. Well, 2, the next one to get to 3 would be a to the third. Well, if I have b to the fifth and I need multiples of 3, I have to get to b to the sixth because both of these pieces are divisible by 3. So now I have to state what is missing here. Well, if I have a squared and I need to get to a to the third, I'm missing 1a. If I have b to the fifth and I need to get to b to the sixth, I'm missing 1b. What you do to the bottom, you do to the top. On the top, I multiply my outsides and then my insides. So my goal here is to simplify the bottom. I'm really dividing 3 into both of these. So left, what I could take out is 1a and 2b. So again, let's look at it. I have a, and 6 b's. So what comes out? 1 group of a's and 2 groups of b's. And on the top, I'm left with 3 and the third root of AB. And there's my final answer.